Hello, math lovers. Today is a great day. We are going to factor. Fabulous. We're factoring polynomials in lesson P4 in notes number 6. So before we get started on our factoring, I want to talk about our steps to factoring. All right, so our first step is to look at for your GCF. All right, your GCF, do you have a greatest common factor that you can pull out? Second step, is it a binomial or is it a special binomial? Is it one of those special products that we looked at yesterday? Is it the difference of two squares? Is it the sum or difference of cubes? Third step is to go ahead with your trinomial, old-fashioned trinomial factoring. I know you did tons and tons of this in your Algebra 1 class. Fourth step is to look at grouping. Is it 4 terms or more that I can break it down into separate groups? I always like problems where you can factor again and again, so look for those. And finally, you have to check your answer, okay? So I'm going to pull some problems today from page 42, okay? These are problems that are in your textbook. I would like you to pull out your textbook and follow along with me. This is no fun if you guys just sit and watch me do problems. You know, it's like watching me do sit-ups. Okay, your core is not going to get any stronger if you're watching me do sit-ups. All right, you're not going to be happy. You're just not going to be happy. All right, with the product. All right, so I'm going to pull some problems out of your book. Hopefully, it gave you some time to open up your textbook to page 42 and you take a look at these problems and we'll go through them. So first, I'm going to look at number 9. I've got 4x plus 16. I want to go ahead and factor that. First step, GCF. Bam. You're thinking to yourself, GCF is 4. Pull that out, and then what do I have left? You know, think about it like Jeopardy. What's my question that's going to yield this answer? 4 times what is 4x? That's x. 4 times what is 16? That's 4, and I'm bringing along the positive sign. I can't do anything else. I double check in my mind, hey, that works, and I move on. I picked 17 on purpose. It's weird. It's just plain old weird, all right? Now, who in their right mind would pull out a 1/2? But, you know, Ron is challenging us to think about these problems a little bit differently, all right? So you got a 1/2 out of both of these. This would be x plus 8 in the parentheses, okay? So a little bit different kind of problem here. I'm not sure I would bother, but maybe you would. Okay, 23. X squared minus 81. Go through your steps. GCF, no. Binomial, yes. Is it the difference of two squares? Well, look at x squared, perfect square. Look at 81. Perfect square. So all I need to do is draw my 2 sets of parentheses. Square root of x squared is x. Square root of 81 is 9. And I make sure my signs are different. Real quick. Oops. Get that white out again. Glennon. I think I got it. Put that minus sign in there, okay? So make sure your signs are different. So those middle terms will fall out when you go ahead and you FOIL those terms together, okay? Let's do number 33. 33, I have x squared minus 4x plus 4. All right, going through my steps. GCF, no. Binomial, no. I got my trinomial. I'm going to go to my trinomial factoring. Now, you guys probably have lots of different methods to factor a trinomial. Personally, I just learned to look at it and let the numbers talk to you. I know that's not like a good algorithm, but you have such a strong number sense. There's a reason that you're in my honors class, that you could probably just look at this and know that the first term has to be x. Then you're thinking, well, let's see, what are my factors of 4? Sum is going to be -4, so I've got 2 and 2. Or maybe you're thinking to yourself, hey, this is one of those special products that we had yesterday. You notice the form, and you can go ahead and write it as x minus 2, the quantity squared, okay? And then we've got number 45. Oh, this is such a good one. Look at this. Oh, you know what I'm thinking right away. No GCF, binomial, difference of cubes, isn't it? Difference of cubes. Remember that day, the first day we were together? We did assignment number 1. That was a great day. That could have been on this worksheet, all right? So what you're thinking to yourself, following your rules, pull out your notes. You're thinking that this is going to be x cubed minus 2 cubed. Do me a favor, write that step. You're going to be so happy you did. Your first set of parentheses, your second set of parentheses, you've got x and x squared. You've got 2 and 2 squared, which is 4. You've got to build that middle term now out of this 2 and the x. And then, friends, you're going to pull out your SOAP, all right? So this first set of parentheses has the same sign, which is going to be a minus. This one is opposite, and the last one is always positive, all right? Do a quick double check. Make sure that that works. Hey, it does. Move on to 57. All right, 57, I've got x squared plus x minus 2. Okay. Right away, no GCF, not a binomial. Looking at my trinomial factoring. So right away, I'm thinking about trinomial factoring. Draw my parentheses. Coefficient here is x squared. That makes it so nice. Factors of 2 are 2 and 1. That's all I have to pick from. Now I've just got to figure out how my middle term can be a plus. If I make this one a minus and this one a plus, is that going to work for me? X squared minus 1x plus 2x. Yes, it will work. Okay. Don't forget that step of checking it. All right, 71. Oh, this is a nice one. Oh, you're going to love this one. X to the third minus x squared plus 2x minus 2. All right, go through your steps. No GCF, no binomial, not a trinomial. We've got to look at our grouping. Now, I got to tell you, when I try my grouping problems, I always try to go with the order. Like maybe it's an easy one. Maybe the order is the way it is for a reason. If I look at these two terms and I look at these two terms, what can I pull out? Well, these first two terms, I can pull out an x squared, right? And what am I left with? If I just think about it as this much of a problem, it would be x squared times the quantity x minus 1, wouldn't it? And what if I just look at this problem? What do they have in common? Well, they have a 2, and I can pull out the 2. So it'd be 2 times the quantity. Oh, look at that. They're connected by plus. Now, think about it. Inside these, there is a GCF of both terms of x minus 1. So think about pulling this out, all right? In your mind, you're thinking about, what if the problem were what if the problem were x squared times something plus 2 times something? Wouldn't that something come outside and look like this? Yeah, let's do that exact same thing. So it's going to be x squared plus 2 times x minus 1. Now take that. Don't trust me. Convince yourselves. Foil this out. Go through all the steps, and you're going to see that all of the steps are there. Okay, really nice one. And then the last kind of foiling problem, which seems to be the favorite of my honors kids, are ones where the coefficient for your term, your variable term here, a 3, is not a 1. All right. Now, I was taught back in the old days, I was taught to just stare at the problem and let it talk to you. I mean, maybe that's all we had back in the 80s was staring as a method. And I would go, all right, 3x squared. Oh, sorry. I know I didn't have a GCF, a binomial. I'm right at my trinomial factoring. All right, back to my staring. So I would do 3x and x. My signs are the same, so I knew plus and plus. And then I do factors of 8. And I might try 2 and 4. I might try 8 and 1. I might try 1 and 8. I might try 4 and 2 and so forth to do like guess and check to get it to work. That's just the way I learned it, okay? Some kids can look at it and just know. Well, that's just what we do. Other kids need a method, all right? So what you're going to do is you're going to take these two terms and you're going to multiply them together, the 3 and the 8. No, there's no GCF, so this is not going to work if you have a GCF. Take the 3 and the 8 and multiply them together, and you're thinking to yourself, that's 24. What are the factors of 24 that are going to give me 10 in the middle? All right, so I go through 8 and 3, negative 8, negative 3, blah, 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 and I get all the way down to 6 and 4. And that's going to work for me. Okay, so what I can do is I can take this middle term, this 10, and I can break it down into 6x and 4x and 8. All right, and then we can go ahead with our grouping. So this would be 3x times x plus 2, write that. And over here, this would be 4 times the quantity, x plus 2. So then I've got the common term there of x plus 2. So it's like I'm pulling out that x plus, oh, sorry. Technical difficulties there. I'm pulling out this x plus 2 and the x plus 2 here. I'm pulling it out, and that's my greatest common factor. And then I'm left with 3x plus 4. So really not that different than my guess and check method that I was working with up here. I said 4 and 2 to start with. So I'm thinking to myself that the 4 has to go here and the 2 has to go here, because this is going to give me 4x and this is going to give me 6x, and this is going to give me 8x. And bam, that gives me the 10x that I wanted. All right, so just another way to solve your problems. Okay, have fun with your problem set. Try some problems.